So this is the pipeline in which we are going to be working today in today's tutorial. This is the end-to-end pipeline of a real-world computer vision project, and this is exactly what we will be covering today. You can see that this is a huge pipeline and we have many different parts, right? It all starts with requirements, then we have planning, we have execution, deliverable, and so on. This is an entire process and it's comprised of many different parts. So the first thing I'm going to do is to explain super quickly each part in this process. I'm going to explain this pipeline and I am going to show you this process in a very specific example in a very specific project. So but for now, let's just start by defining each part of this process and by explaining what exactly are the requirements, the planning, and so on. So when you are working on a real world problem, someone is hiring you to build this project, to build this solution, to solve this problem, right? There's someone who is paying you, who is hiring you to work on this project. That someone is usually your client or your employer or something like that. And that someone, whoever that will be, is going to give you something that looks like a list of requirements, right? The project is going to be specified by a list of requirements, and this someone, this client, is also going to give you a budget, right? So it all starts, this entire process, this entire pipeline starts by a client giving you a list of requirements and a budget, telling you exactly what's the project you need to build, right? If you don't have the list of requirements, there's nothing you can do. If you don't have requirements, you have nothing, right? Because you can see that all the other parts in this process come after the requirements. So if you don't have a very good specification of requirements, you have absolutely nothing and you cannot build absolutely anything. That's very important. The requirements are the most important part in the process, and this is where everything starts. So for now, just keep in mind that the requirements are a list of specifications that you are given when this project starts, right? And these requirements define exactly what's the project you are going to be working on. And then after you have your requirements and your budget is when you go to the planning, and this is where you are going to take everything you have to do, everything that's specified in the requirements, and you're going to see exactly how you are going to solve the problem, how you are going to deliver exactly what you need to deliver for this project. This is done in the planning stage. This is where you're going to build a plan to work on this project. And then after you have a plan, you go to the execution part, and this is where you are going to execute this plan. This is where you are going to take absolutely every single task in this plan and you are just going to execute it. This is where you are going to do all your coding. This is where you are going to build your functions. You are going to build your models. You are going to prepare the data. You are going to do absolutely everything you have to do. You are going to do it here in the execution part. After you are done executing absolutely all the plan for this project, you are going to prepare your deliverable and you are going to deliver the project to your clients, right? You are going to deliver what you need to deliver for this project. And once you have completed your deliverable comes the testing, right? This is where the client is going to take your deliverable and it's going to see if your deliverable meets all the requirements in which were defined here, right? This is where the client is going to test absolutely everything you have done, and from here you can go either to the execution again, because if the client notices there's something missing or there's something wrong or if there's a bug or something like that, it's going to ask you to fix it so you can go back to the execution again. And then it's just like an ongoing iteration. You are going to go through the execution and the testing once again until the client is happy with your deliverable. And when that happens, then your client is going to approve the deliverable, and that's going to be pretty much all for now, because after the deliverable was approved, you go to a final stage, which is maintenance, right? Once you have delivered your project and once your client is happy with that project, it doesn't really mean that project is over, but you are going to continue working that project, as a matter of speaking, because after that comes the maintenance, and it means that you have to maintain whatever happens with that project, right? Remember that when you are working with building models, computer vision, machine learning, when you are working with software, things happen over time, things happen. Maybe you have delivered a server, maybe you are serving a model through a server and the server goes down and you have to fix it, or maybe the model doesn't work very well for some reason, or maybe, I don't know, something happens, and anything could happen, and usually things happen. You know how it is, you know how software works, so usually there will be things you need to take care of over time. There will be things you need to maintain. So this is pretty much how the overall process looks like, and this is pretty much how this each part of this process means. And in today's tutorial I'm going to explain a more simplified version of this pipeline, because we are going to work here, which is exactly the same process, but we are keeping the maintenance out of this pipeline. The maintenance is definitely a very important part of this process, and this is going to be in absolutely every single project you take, absolutely every single project you do. You are going to deal with maintenance for sure. That happens, it's real, and it's part of this pipeline for sure. But it makes things a little more complicated, because it takes a lot of experience to know how to plan for the maintenance, how to adjust the budget so you can include the maintenance. You need to define exactly what's going to be included in this maintenance, exactly what you are going to take care of, and exactly what you will not be taking care of. When it comes to the maintenance, there's usually a discussion, or sometimes it happens that there are issues because the client considers that you need to fix something, but you, the developer, the freelancer, someone who is working on the project, considers that that's not something to be fixed, but that's more like a new feature to the project. Sometimes it happens that there are discussions around what is considered maintenance or not. So in order to keep it simple in today's tutorial, let's just keep the maintenance out of the way and let's focus on everything else. So this is the more simplified pipeline in which we are going to be working today, and this is what I'm going to show you how it looks like with a very specific example. So let's start working on this project and let's start working on the requirements. So the project I have prepared for today's tutorial is an image background removal project. This is what we are going to be working today, and these are the requirements for this project. So let's see how these requirements look like. And when it comes to the requirements, I have to say that although we are going to work on a very simplified list of requirements, things could get very crazy when it comes to the requirements. Sometimes clients specify like a very comprehensive list of requirements. They specify absolutely every single detail they want for this project. So things could get as crazy as you can imagine, right? And if you search online for requirements engineering, you are going to see there is a lot of science involved on how to specify a very comprehensive and a very detailed list of requirements, how to structure the document, and so on. But in this example, in this video, in order to keep it very simple, I have prepared this very simple document specifying the requirements for this project. So let's go through it. This is for an image background removal project, and the project description is build an image background removal model and serve it through an API, right? And you can see that although this is only one sentence, this explains exactly what you need to do on this project. You know exactly what you have to do. You have to build an image background removal model and you have to serve it through an API. So although this is very simple, this is very detailed, right? This explains exactly what you need to do. And then about the requirements, you have three different sections in the requirements. The first one is related to the model specifications, and it says the input will be an image in JPG or PNG format in BGR of any size. The output will be a BGRA image in PNG format, same size as the original image, with its 4 channels set to 0 in all pixels where the background was removed, right? Then the model will be optimized in the case of a single person, full body in front of a background with no other people, and it's preferable to build a model without collecting and annotating custom data. All resources used to build this model should be open source. And then this is very important because it says the model will be optimized in the case of a single person, full body in front of a background with no other people. And this is I think this is the most important requirements of all, because this is telling you in what type of data, in what type of images this model will be applied on, or will be mostly applied on. If we are thinking in an image background removal model, we could make it work in absolutely every single type of images. We could be removing the background of, I don't know, an image containing a car or a house or an animal or a cat, a dog, a horse, or and so on. And this could lead to some confusions because, for example, if there is an image containing a car and a person next to it, what are you going to consider as the object and what are you going to consider as the background, which has to be removed? You could say, okay, the person is the object and everything else is the background, or you can say the person and the car is considered the object and everything else is the background. There is some discussion on what could be considered the background you need to remove. So in this case, it says the model will be optimized in the case of a single person, full body, in front of a background with no other people. So this is very important because it's telling us exactly what type of images we will be getting in our background removal model, and exactly what will be considered the object and exactly what will be considered the background. So for example, we are going to receive images that look like this. We are going to have a person in front of a background. Let me show you this here. I have prepared a few examples. Or we will have something like this, which is also a person in front of a background, or we will have something like this, right? This is exactly the case, the type of image in which we need to make our model to work best, right? This is the type of image in which the client is going to test the model. So this is very important, and this is one of the requirements. This is very, very, very important because otherwise we will be making a generic image background removal model, and that would involve an even more complex problem. But given this requirement, this is going to be fit and this is going to be optimized in this case, a single person, full body, in front of a background with no other people. Then it's preferable to build a model without collecting and annotating custom data. This is also very important because this is actually a very common requirement in many projects. Although machine learning and computer vision, if we want to build a model, it requires that we gather data and we annotate data and we train our model with this data and so on. This obviously it's not free. So once you're working in a project, if there is a way to go around this data collection and annotation and this training process and so on, if we could build a model without going through all that process, it's much better for the client, right? Because all that machine learning process of creating a model is not free. Someone has to pay for that, and depending on the use case and depending on the application and so on, collecting and annotating data could be very, very, very expensive. So this is another requirement. It's preferable to build a model without collecting and annotating custom data. So this means that we have to either build our model by taking pieces of other models we find which are publicly available, or we have to take data which is publicly available, which is already collected and annotated. So this is what this requirement means, and this is very important because this is very much like a real life computer vision problem or a real life machine learning problem. Collecting and annotating custom data is very, very expensive, and this is something that we have to do only if there is not an alternative. So that's what this requirement means. And then all resources used to build this model should be open source. This is also a very good example of how the real life problem looks like, because sometimes clients are very concerned with copyright and they don't really want to use anything that's not open source. So this is another requirement we have to meet. And then we have some specifications regarding how to make our deliverable. We are being told exactly what we need to deliver. So we need to deliver an API endpoint, because remember, this is a model which will be served through an API. Then some basic documentation on how to interact with the API, and documentation on how to retrain the model, right? We are going to build a model and we're going to serve it through an API. So we have to deliver the API endpoint, and also we have to deliver some documentation regarding how to retrain the model if the client needs to retrain it. And then we are given 80 hours to complete this project. This is the budget for this project. And these 80 hours actually means that we are given this amount of money, right? So depending on how much you charge for the hour, this is how much money you are going to be assigned, right? For example, in my case, I usually charge something like $50 an hour. So this means I will be getting $4,000 to complete this project. And then another restriction regarding the budget is how much time, but how much real time you have to complete this project. And it says the deliverable should be ready 2 weeks after starting the project. So this is how much money we have in order to complete this project, and this is how much time we have to complete it. 80 hours translated into money, and then 2 weeks. So this is a very good example of how a list of requirements look like. And a very quick note is that although this is given at the beginning of the project, and this is obviously very important, and if you don't have the requirements, then you have nothing and you are building nothing, you are doing nothing. If you don't have the requirements, you don't really have a project, there's nothing. Sometimes you are not really given a document, right? Sometimes this is something like a conversation you have with the client. The client says what he wants or what she wants, and you just have to work from there, right? Sometimes you, as the freelancer or as the developer, should write this list of requirements based on what you have discussed with the client. So having the requirements for the project doesn't really mean you're going to get a very, very detailed and very nice looking document as I am showing you here, because sometimes clients are more like, they only have like a conversation with you, and you have to write the requirements from there. But anyway, this is how we are going to do it in this project. These are going to be the requirements for today's project. And now let's move to the planning. The planning will be the next stage on this project, and this is where we are going to take these requirements and we are going to build a plan. So now let's move to the planning. This is where we are going to take all these requirements and we are going to build our plan. We are going to specify exactly what are all the different tasks we are going to do in order to reach our goal, in order to fulfill our requirements. And this is the plan I have made for this project. This is Gantt Pro, which is a project management tool. This is an app you can use online. This is one of the many project management tools which are available, and this is the one I have used for this project. So let me show you all the tasks I have prepared for this project, for this execution, in order to fulfill all these requirements. So the first task you can see over here is state-of-the-art review, and this is actually the first task in pretty much any machine learning or computer vision project. It all starts with a state-of-the-art review. Usually this is the first step in absolutely every project, because the idea is that you want to be more familiar with absolutely everything that's already available, and all the different resources and all the repositories and all the papers and all the absolutely everything that's available and everything that already exists in this particular niche. In this case, this will be a state-of-the-art review in image background removal stuff, right? We are going to see all the repositories, all the papers, all the everything. We want to get more familiar with this niche. We want to get more familiar with this field. Then after this state-of-the-art review, which is a very important step, and it's like, remember, this is the first step in most machine learning projects, it comes the implementation. This is where we are going to see exactly what we have found in this state-of-the-art review. We are going to take all the repositories, we're going to take all the papers, we're going to take everything, and we are going to implement an algorithm. We are going to implement an image background removal algorithm. This implementation could be as simple as just taking a repository, cloning an existing repository, and to use this repository out of the box. It could be as simple as that. That's what I mean implementation. We will not be implementing anything, but it could be something as simple as that. Or it could mean taking a paper describing a very novel approach or something that's, exactly the algorithm we need in order to solve this problem, and it involves to implement the algorithm described in this paper, right? This implementation, the one that it's described in this step, it could mean many different things. It could be something from scratch, from complete scratch, like implementing a paper, or it could mean like cloning a repository and just using this repository out of the box. After we have completed this implementation, it comes the testing, right? We want to test this implementation to see how it performs and to see if this is something we can use for this project. After a successful implementation, it comes the API setup, because remember, we need to serve this model through an API. So we need to set up this API, then we need to test this API, Then we have an algorithm and we have an API. We need to integrate these two things. So we need to integrate the algorithm with the API so we can serve the image background removal model through the API. And then it comes the test of the overall system. Now we are testing the API, the model, and how we are serving this model through the API. And then we need to prepare the deliverable, right? Because remember, we need to prepare a few things for this deliverable. We need to deliver the API endpoint, the basic documentation on how to interact with the API, and basic documentation on how to retrain the model. So there are many different things to prepare. So this is how the plan looks like in this particular case. And there are many quick notes. There are many things I have to say regarding this planning. The first thing is that you notice that we are given 80 hours, right? We are paid for 80 hours. But if you see all the tasks and all the estimations I have prepared for each one of these tasks, you can see that the sum of all these different estimations is 60 hours. So we are not using the 80 hours we are being paid. And this is a very common practice because this means we have a buffer of 20 hours in this project. So if something doesn't really go as expected, then we can just use some of those paid 20 hours which we are not using in this plan, right? So that's the first thing to notice, and that's very important because that's something that's very common when you are working in when you are planning a project. It's very healthy to keep some hours apart, right? To have a buffer with some hours you can use in case something happens. Because usually things happen. Usually unexpected things happen in a project, so it's always a good practice to keep some hours in something like a buffer, right? So you can just use them if you have to. So that's the first thing to notice, but there are many other things. From this entire pipeline, I can say that there are some things which are which have more risk than others, right? There are some parts of this process which are riskier than others. And for example, the state of the art review, this is not risky at all. We are just going to make a review. We are going to see all the resources which are available. Setting up an API, I will say it's not very risky either. I mean, this is something I have done many times and I know exactly how to do it. So there's not a lot of risk involved here. Then testing the API exactly the same. Then integrating the algorithm with the API, there could be some risk because we have to see exactly what algorithm we are using. And then, but assuming that we haven't had any issue with the algorithm, this should not be a problem either. And then preparing the deliverable, this is just writing a few documents, so this is not risky either. I would say all the risk in this project, most of the risk of this project, 99% of the risk for this project is here in implementing the algorithm in a local environment, right? Implementing the algorithm we have found, or some of the algorithms or the papers or whatever we found in this stage. This is where we have most of our risk because we cannot know beforehand. There's no way to know what exactly we will find in the state of the art review. We don't know if there's something which is already available and completely ready to be used, or if we have to do something from scratch. If we do have to build something from scratch, maybe we have to train it from scratch too, and we need data and we need to, I don't know, there's a lot of risk involved. Also, if we are going to be reviewing repositories, you know how it works. You know that things happen sometimes when you are trying to reproduce a repository, when you are trying to execute a repository. Sometimes you can do it out of the box, and sometimes things happen. So there is a lot of risk in this implementation. This task, which I have set with 20 hours, as you can see here, it's actually very risky, and this is very important because everything else depends on this, right? It's very important to identify what are all the risks in this project, and in this case, this is where we have most of our risk. And obviously that the more experience you gain and the more projects you take, you start getting some intuition regarding what's the risk associated with different fields or with different types of projects. And I will say that in this case, as we are working on image background removal, I will say it's very likely that we are going to have a successful implementation, right? I will go even further on that, and I will say it's very likely we are going to find a GitHub repository, more than one GitHub repository that we can use pretty much out of the box, right? That's what my intuition about this problem tells me, because image background removal is not really like a super complex problem. There's a lot of literature about that. The problem have been solved extensively. So I will say it's very likely we are going to find repositories we can use pretty much out of the box. Maybe we need to do some retraining, some fine tuning, something like that. But that's only an assumption I'm making for this part, for this process, and we don't know for sure if that's going to be the case or not. So this is where we have the risk in this project, and you can see that I have estimated 20 hours, and this is where I think we will use the remaining 20 hours, the buffer of 20 hours that we are not using and we are not seeing in this project. If something happens, this is where we will need to use this buffer. And I think that 20 hours and using maybe 20 hours more, using 40 hours in total, it should be more than enough to complete this part of this process. But let's just hope that my assumption is correct and we don't really need to work as many hours, or we don't really need to take risks in this part. And then let me show you the estimates for each one of these tasks. You can see that I have not only I have prepared each task, but I have also prepared an estimate. In the case of the state of the review, this is 10 hours. Then the implement the algorithm in a local environment is 20 hours. Then test the implementation, test this implementation for this algorithm is 5 hours. Then setting up the API is 2 hours. Testing the API 1 hour. Integrate the algorithm with the API 10 hours. Test the overall system 2 hours, and then prepare the deliverable 10 hours. This is very important because you have to think about all the different tasks, all the different steps you have to take in order to reach your goal, in order to prepare your deliverable. And not only you have to think about all the different tasks, but you also have to estimate these tasks. This is very important. It doesn't really matter if you use an app like this. It doesn't really matter if you use Gantt Pro, if you use Jira, if you use Trello, or if you just prepare the plan in a notepad, right? If you just think about all the different steps, all the different tasks, and you just write them down in a notepad, you can perfectly do something like that. I have done that for many projects, and I will do that for this project too, but you know how YouTube is, and if I show you something more visual, it's going to be better. So that's all about the planning. This is the plan I have made for this project. This is the plan that I have made in order to prepare a deliverable that meets all these requirements. So this is the plan in which we are going to be working in the execution part of this pipeline. So now let's move to the execution part. Let's see what happens. So let's start with the execution, and you can see that the first task in this process is the state-of-the-art review. So this is the state-of-the-art review I have prepared for this project, and you can see the structure for this document. I have made a review of repositories, papers, and also products, and also other resources, right? If I show you the index, you're going to see we have repositories, papers, products, and other resources. This is a structure I have chosen for this document, and the idea is that you want to take a look at all the available resources. It doesn't really matter how you structure this document, but the idea is that you take a look at everything that's publicly available. So these are some repositories I have found, and I think that they're going to be very useful for this project. These are some papers and so on. The idea with the repositories, the idea when you are reviewing repositories, is to take a look at everything that's available and everything you can use in order to build this project. So you are going to find many different repositories, many different repositories. And the idea is to choose the most popular ones, or to choose the most suitable for your specific project. And this is the way I usually do it. I just write the repository URL, and then I write some comments so I can see exactly what's the benefit, or exactly what's the what are the parts of this project or this repository that I am most interested in. And also, when you are reviewing repositories, the idea is to have a healthy repository, or something that you think it's going to be a very good shot in order to build your project. Because we have all been in that situation where we are cloning a repository and we are trying to reproduce everything that's written on that repository, in that project, and we have some challenges, and we have some errors, and we have some bugs, and so on. So the idea is to use repositories which are very well maintained, which are very popular, which are very recent also. So those are the things I look after when I am reviewing repositories. I want something that's on point to the project I'm working on, and also I want a healthy repository. I look at all these different estimators, and I take a look at that's a healthy repository. That's something that's very likely for me to reproduce everything that's written on that repository. So, for example, you can see that the first one in this list is REMBG, and it says recent changes, extremely popular, CPU and GPU, comprehensive README, MIT license, retraining possible. Besides the source code, it's also available through a Python package and a Docker container. And these are some comments I have made by looking at the repository, by looking at the README, by just taking a look at everything that's on this README file and on all the different files and so on. I haven't tested anything, right? I haven't implemented anything. I haven't cloned this repository. I haven't tried to reproduce the results or anything. I am just writing some comments based on what I'm seeing here. So the extremely popular is because you can see that this has 7,800 fabs, 7,800 stars. So this means this is very popular. There are many people who have been very happy with this repository. Also, this has been forked 994 times, which is a lot. And you can see that with the most recent changes is from last week. So this is very, 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 very recent. This is a very healthy estimator. So these are definitely some good signs regarding this repository. This is something I really, really like. You can see this is the CPU and the GPU support, so that's also a very good thing. And if I scroll down, you can see that you can also use this repository or this algorithm as a Docker, right? There's a Docker image for this repository, so this is a very good thing. Also, we have some snippets which we can use in order to see how we execute it if we decide to use it as a Python package. So this is a very, very comprehensive README, and this is a very good candidate, right? This is why this project is is one of the repositories I have selected, and this is why this is the first one in the list. So remember, this is only a review. We are reviewing different algorithms. We are reviewing different resources. We are not wasting too much time. We have 10 hours in total for this state-of-the-art review. This is how much time we have estimated. So the idea is just to go through all these different things and to see all these different estimators and if this is something we can use and so on. So this was a very, very good candidate. And also the MIT license, right? If I show you the license, you can see that this is an MIT license which says it allows distribution and commercial use and so on. So this was one of the project requirements, right? The client was concerned with copyright and so on. So in this case, this repository definitely meets this requirement. Then moving to the next one, you can see that in this one I have written, this is a popular repository. It has some recent changes. It also has a demo app. It has an MIT license and it's based on PyTorch. So this is also another good candidate. If I show you this repository, these are how many stars it has. It doesn't have so many as the previous one, but nevertheless, it's a very good, it's a very popular repository. And also, as I mentioned about the demo app, I think this is somewhere around, let me find it here. And I have already used this app with a few examples and I see that this performs very well. So this was a very quick way to test this repository and that makes it a very good candidate as well. So we have these two and then I found this other one. Obviously I found many, but these were the three most important ones. And this other repository, which although it was a very good candidate, I don't think I'm going to use it because it doesn't have a license. So it appears it's not available for commercial use, so it doesn't meet one of the requirements. But nevertheless, it's always a good idea to just write down absolutely all the resources or all the most important resources you find on the field. So you can then make decisions, right? Later on, you can make a decision regarding all the different repositories, all the different resources you have found. And remember, you are looking for repositories and for papers and for everything you can use in order to build this project, but you also want to become more familiar with all the different techniques and everything that's already available in this niche. So, although we cannot use it because it doesn't have a license, it doesn't have an open source license, we can just, it's very helpful to write it down too. Then about some papers, there are many papers describing very novel algorithms which don't disclose the code, the dataset, the model, and in some cases the paper is not publicly available. So when I was reviewing papers, this is what I found. There are many algorithms, very novel algorithms, very robust algorithms for image background removal, but it doesn't really appear to be very helpful for this project or for this case, because these papers, I didn't really find the code or the dataset or anything. So yeah, nevertheless, I wrote down some of these papers, so we know that they exist. We know these algorithms are available, and we know everything is there. Then I also reviewed some products, and that's a very good thing to do, because we want to become more familiar with absolutely all the literature and absolutely all the resources there are, and it's very helpful to take a look at what are the existing products of other companies or software as a service web pages and so on, offering a similar product. That's something I have found is very useful when doing a state-of-the-art review. Because, for example, I have found these apps, and once we have our algorithm or image background removal algorithm, we can always use these apps as a benchmark, or we can also use the API which is provided in these apps. We can use these apps, we can use all these products in many different ways if we know they are there, right? If we know they exist. So that's why I have also reviewed some products, and this is something I usually do when I am making a state-of-the-art review. And then I have prepared this section of other resources, because when I am doing a state-of-the-art review, there are some resources, there are some things which are not really repositories or papers or products, but they are very interesting resources in order to make this state-of-the-art review. They are definitely something I want to keep in mind when I'm working on this project, or maybe these are interesting resources to consider in other projects. In order to give you an example, this is a very interesting repository I found when I was doing this state-of-the-art review, and this is actually instead of removing the image background, this is removing the person from the image, and it's keeping exactly the background as it is, and it's keeping only the background. This is like the opposite project. Instead of removing the background, it's removing the image. It's removing the person from the image. So yeah, I thought this was a very interesting repository, and this is why I wrote down this repository in this section over here. So this is like a list of other stuff I consider interesting, and they are on point on this project, kind of. So this is the state-of-the-art review I did for this project, and in this particular case, as I found such a healthy and recent and extremely popular and such a comprehensive repository as this one, this is a very good candidate to work on this project. This was a very successful state-of-the-art review, because in some cases you don't really find something that's this nice looking. You don't really find something which is like so comprehensive and so healthy and so on. And in some cases it's needed to implement something from scratch, or to clone the repository and to compile it and so on. But in this case, I am very happy that I found this, which is a very good candidate. You never know until you test it. You never know. So, but nevertheless, I was very happy when I found this repository. So this is the most important conclusion from this state-of-the-art review. We found a repository which seems to be a very good candidate to use as our image background removal model. So now let's continue with the execution part, and now let's move to the next task, which is implement this algorithm in a local environment. And this is exactly the algorithm which we will implement. And by implementing this algorithm, I mean making sure we can just set this algorithm up and running in our local environment. So what I am going to do is I am going to PyCharm. This is a PyCharm project I created for this tutorial. And what I am going to do is I will try to execute the snippets I have in this README file to make sure I can just execute this repository to make sure I can just use this image background removal model out of the box. That's what I'm going to make sure, or if I need to do some additional work, and if I need to do some additional adjustment, this is what I'm going to find out now. And from all these different snippets, I'm going to use this one, which is iterating this process through all the images in a directory. So this is exactly what I'm going to do. I'm going to PyCharm. I'm just going to copy and paste this snippet. That's all I'm going to do now. And I'm going to install this package. So I'm going to the terminal, pip install. Let's see exactly what's the pip install I need to execute. I'm going to pip install the CPU version, pip install rambg. In my case, nothing is going to happen because I have already installed this library when I was preparing this video. And now I will try to execute this snippet. Let's see if everything works out of the box. And I'm going to try to execute it with some images I have prepared in this directory. So I'm just going to copy this directory and I'm going to paste it here. And I'm going to iterate in all images, in all extensions, because I have JPG images and also PNG images. Okay, now I'm going to press play and we have to wait a few seconds. Remember, we are iterating in all the images in this directory. This is a directory containing many different images with people in a very clean background, or at least there's no other people in the background in these pictures. So this is data which looks pretty much the data the client is going to use when it's testing this algorithm. Remember, we need to fit this algorithm, this model, to this situation. Should be optimized in the case of a single person, full body in front of a background with no other people. So this is exactly the type of images I have in this directory. And let's see what happens. Okay, so the execution is now completed. Let's see what happened. And this is the directory containing all the images we originally had in this directory, and also all the images which we have removed the background on. Let's see what happened in these images. So let's start over here. This is the first image, and you can see that this was the original image and this was the image with its background removed. I think it works very well. This was another example and this is the image with the background removed, and I think it works very well too. This is another example. In this case, we have removed the guy's jacket, and I'm not sure if that was supposed to do, or if we should have removed it or not. That's a discussion if that was part of the background or not. But nevertheless, I think this is a very good result and we can perfectly use it. In this case, we have a similar situation with this guy's jacket, but I think it's a very good result nevertheless. In her case, it's working very well too. In his case, I will say it's working very well too. It's working well too. Yeah, we are removing the background in all these cases. In her case, we have a situation here in the hair, but I would say it's okay too. I mean, it will be very hard to remove all these parts within the hair in any other case. So yeah, and in this case it's working well too. In this case it's working well too, and so on. You can see that we have some very good results in the images I have prepared in this directory, right? So yeah. This is only to test how this performs, and we are back to the first image. I have selected this image actually because I noticed her skin tone is very similar to the background, so I was very curious to see how the algorithm was going to perform in this image, and I was surprised to see it performed super well. So I am now confident that this is a very good image background removal model. And not only that, but you notice how simple it was to execute this algorithm, to execute this process. So this means this is going to be very easy to implement. This is going to be very easy to use. And this is how simple the implementation was in this case. The only thing we had to do is to pip install this library and then just test the snippet. This one of the snippets which is provided in this repository, and that was it. And this is very important because we originally estimated 20 hours for this implementation. We originally estimated this task as it was going to take 20 hours, and it took what, maybe 5 minutes, 5 minutes or so. So it means we have most of this time available in this process, in this pipeline. Now we have more time we can use as buffer, right? Everything we can do even quicker as we estimated. It's a very, very, very good news, because this is additional time we can use later on if something happens in another part of the process, right? It's a very, very good news. And also we have also completed the testing, because what I have just showed you, this implementation and this iterating all these images, this is a way to test the algorithm, to test the implementation. So I would say both the implement the algorithm in a local environment and also test this implementation, these two tasks are now completed. So perfect. And we have completed these two tasks in only a few minutes. So let's continue with setting up the API, which is the next task, and let's see how we go from there. Now moving to the API, let me show you exactly what's the repository we are going to use in order to set up this API. This is the repository I created for today's tutorial. I am going to post a link to this repository in the description of this video, and you can see that I have written absolutely all the pipeline in which we are going through in this video in the README file of this repository. So remember, I'm going to post a link to this repository in the description of this video. But for now, let's focus on the API. Let's focus on this part, because I am going to follow all the different steps which are described in this README file, in this repository, so we can set up this API together. We can set up this API in this process. In order to do that, I am going to use an EC2 instance from AWS, and this is how we are going to do. The first step is to launch an EC2 instance. So this is my EC2 dashboard in AWS, and I'm going to instances, and I'm going to launch a new instance. I'm going to name this instance API, something like background removal API server. Okay, and I'm going to choose Ubuntu. This AMI is fine. Then the instance type needs to be T2 X large, and then the key pair. I'm going to select my key pair. If you don't have a key pair, this is time to create a new key pair, but I already have one, so I don't have to select a new one. And that's pretty much all. So I am going to launch my instance, and then let's see how we can set up this API into this instance. Let's SSH into this instance. So I'm going to here, and then I'm going to copy the instance IP, and I'm going to do something like, because it's going to be easier if I just copy paste. So copy paste and then copy and then paste. Okay, so this is yes, and I'm now into the EC2 instance I just launched, and let's see what's the next step. Once we are into the EC2 instance, we need to run these commands. So I'm going to run these commands one by one. We are going to use nginx in order to set up this server, in order to set up this API, and also we are going to use fast API. So this is going to be a very, very quick process. This is a very easy way to set up an API, and this is how we are going to do. I'm going to run the second command. And in the meanwhile, let me show you what's the code we are going to execute. We are going to execute this main file, and you can see that this is a very simple script. This is a very, very, very short script. We only have a few lines. Remember, we are using the fast API library, and basically what we are doing is we have only one method, which is a post method in this API, and we receive an image URL. We are going to receive an URL containing the containing an image. This is going to be the URL of a given image, and we are going to download this image using this instruction. Then once we have downloaded this image into our server, we are going to read it using CV2, and then we are going to use the RamBG library I showed you a few minutes ago. So, and once we have removed the background, the only thing we need to do is to upload this image into another server, in this case I'm using an S3 bucket, but obviously you can use pretty much anything you want. And once this image is in the S3 bucket, the only thing I'm going to return is another URL to the image I have uploaded into the S3 bucket. This is the only thing we are doing with this API. This is the only thing we are doing in this main script, and this is exactly the app we are going to deploy using EC2 and Fast API, using EC2 and this utility I have just installed. So let's go back to the README file so we can see how we continue. Setting up this API will be a very quick process, and now let's see how everything goes. Now we need to run this additional script, this additional command. I'm doing these commands one by one right in front of you in this video so you can see exactly how this is done. So now I'm going to run this, and I need to paste this config, and in the server name I need to copy and paste this value. So something like this. Okay, so now let's see how we continue. Then we need to start this server, so we need to do something like this, and we need to update the EC2 security groups so we can access the port number 80. So I go to security groups, edit inbound rules, add rule, custom TCP, port 80, and then anywhere IPv4, save rules, and that's pretty much all. If I'm not mistaken, I think we don't really need to do any additional configuration in the EC2 instance, so that's going to be pretty much all here. And then let's go back here. So we have already set up our server, everything is pretty much ready. Now the only thing we need to do is to clone this repository into this server. So I'm going to do something like this. And now let's continue. We need to cd into this directory, and I'm going to create a virtual environment, but the first thing we need to do is to install virtual env. Then I am going to create a virtual environment using Python 3. If I'm not mistaken, it's Python 3.10. Any Python 3 will be fine. I need to activate this virtual environment and install all the requirements in this repository, which are only a few. It's only these 3 libraries. Now let's go back and let's see what's the next step. So once all the requirements are installed in this server, the only thing we will need to do now is to run this additional command. So now I'm going to copy and paste this command, and that's going to be pretty much all. And please notice that we are moving a little quickly actually because we are doing many things at once, following this roadmap, this planning. Now we are setting up the API, we are going to test the API once everything is set up, and we are integrating this API with the algorithm as well. Remember that from the script I showed you a few minutes ago that the algorithm, this background removal algorithm, is already integrated into this process, into this setup. So this is the post method we have created, and this is already integrated with the background removal process. So we are doing many things at once, and this means that we have more time in our hands, right? We have more time to spare in this project. We have an even larger buffer, which is amazing. So going back to the server, we can see that this is up and running, everything is going well. We have launched the app, and now if we remember what's the IP of this server, I'm just going to copy and paste this value, and this is where we have our background removal API up and running. So I'm going to click enter. It says not found because we haven't really specified what happens in the root directory, right? We only have specified this post method. So what I'm going to do now is to access this value, and this is the post method we have created. But let's see exactly how we can execute it. And something that's very helpful from Fast API is that we can access docs, and this tells us exactly how we can execute this API, right? This tells us exactly how we can execute this method, and you can see that this is a list of all the methods we have in this API. Obviously we have only one, we have set up only one, and this one, remove bg, is a post method, and we can try it out if we want. So we can just continue to the next step in this process, which is testing the overall system, right? Now we are here, we are testing the overall system. We have set up our API, we have integrated our API with the background removal algorithm, and now we are testing the overall system. So in order to do that, we need an image URL. Okay, I found this image from Lindsay King Sarah Banks. It seems she's famous or something. It doesn't matter. This is exactly the type of image we are looking for, because it's a person in front of an empty background or in front of a background with no other people. So I'm just going to take the URL. I'm going to paste it here. I'm going to click execute. And now let's see what happens. And we got an error, obviously. So this is exactly why the testing is needed, because sometimes there are some things going on. So let's see exactly what's going on. I'm going back to the terminal in which I have launched this app, and it seems the problem is in line, let's see, here, which is line 39 in remove bg. So if I go back to main, this is using an S3 bucket, and we are uploading an image into an S3 bucket, but in the file I have created in this GitHub repository, obviously I haven't specified the bucket name. This is empty, and also the credentials are empty, right? This is another file which is here, but this is empty. So it's going to take me a few seconds, but I'm going to paste this information here. I'm just going to fast forward this a couple of minutes while I complete these two fields. Okay, so I have completed the credentials. I have specified my secret key and my access key. And now for the bucket name, I'm just going to select one of my buckets, which is a bucket I already prepared for today's tutorial. It's a public bucket, which I'm most probably going to delete after this tutorial, but for now let's just use it, this bucket. So I'm going back here, and that should be all. Okay, so I have updated my credentials and I have updated my bucket name. So now I'm going to launch this process again, and let's see what happens. So I already have the URL of this image, so let's see if I can just use it now. This should be okay, right? I'm just going to yeah, this is running the same URL, so this should be fine. I'm going to try it out, execute, and let's see what happens now. Okay, now I'm getting something. I'm getting a response, which is the URL of the removed image, of the image with the removed background. So let's see exactly how this new image looks like. I am very excited. So I am downloading the response, which is exactly what we should be getting. It's exactly the image we input, but with the background completely and absolutely removed. So everything seems to be working super properly, and we have just completed the test of the overall system. Everything is ready to be delivered to the client. So yeah, we have completed all the steps in this process, in this planning. The only thing we need to do now is to prepare the deliverable, because remember, from the requirements we need to deliver these three things. One of them is the API endpoint, then some basic documentation on how to interact with the API, and then documentation on how to retrain the model. So let's work on that. Let me show you exactly the deliverable I have prepared for this project. Okay, so this is the document I will deliver to the client in a project like this, based on everything we have done so far and based on the requirements we had for this project. The client is requesting the API endpoint, so we have a section which is API endpoint. The image background removal service is available through the endpoint, and this is exactly what we have over here, right? This is the this URL and this function, this method. So going back here, then about the API usage, remember we need to make some very basic documentation on how to interact with the API. So I specify documentation and examples regarding the API usage are provided at this URL, which is exactly the URL we are using now, right? It's this URL. So this is the basic documentation which comes by default with Fast API, and I think this is enough in this case because the client is requesting a very basic documentation on how to interact with this API. By following this example, the client will know for sure, will understand how to interact with the API, how to form the request, how to receive the response, and so on. So this will be more than enough. And then about the model, because we also need to provide documentation on how to retrain the model. And this is also described in one of the issues in the GitHub repository we are using. In this repository, in the one we are using as the background removal algorithm, at the end of this repository, there's something like how to retrain your own model. If you need more fine-tuned models, try this, and this is a link to one of the issues in this repository, and this is a very, very detailed description of what you need to do in order to build your own model, right? In order to retrain these models or in order to build your own. So this will do. This will be just fine. So we have completed the last step in our execution process, which is preparing this deliverable, and now everything is just ready. The next step in this process will be to, if I go back here, the next step once we have completed all the execution is to make our deliverable. So this is what we will give the client. We will give the client this document specifying absolutely everything we have done so far, specifying the API endpoint, also how to use this API, and some instructions on how to train a model, right? So this is what we will deliver, and then comes the client testing. This is when the client will test our deliverable, and the client will make sure everything works as expected. And for the sake of this tutorial, let's just assume the client tests the deliverable and everything works just fine. Everything works super smoothly and everything meets the requirements. So the client approves the deliverable, and that is it, and that's over. Yay! So this is going to be all for today. If you enjoyed this video, I invite you to click the like button, and I also invite you to tell me what you think about this video in the comments below. My name is Felipe, I'm a computer vision engineer, and in this channel I make tutorials, coding tutorials, where I show you different projects and different applications of machine learning and computer vision. If these are the type of videos you're into, I invite you to subscribe to my channel, and this is going to be all for today. See you on the next video.